Looks like we are live. And so I'm always, as usual, I start a little bit early, so I'm just going to wait for a few minutes till we get people here. But I will cover at the beginning for people that are watching this offline, later after the fact, that this is going to be just a little bit shorter video tonight, just trying to troubleshoot a couple things that are still kind of hanging out there. So if you remember from the last video, I had the overdrive working, the preamp boost working, and the signal working. But after I got off the video, I started playing around with it a little bit, and the noise started. I never had it up to max volume because I didn't want to, as I mentioned, wake anybody up. But I ended up playing for a while, and all of a sudden the output just started getting really weak, and it's now at max volume is not very loud at all. So I did try and bias it a little bit and do a few other things, but I think we'll just go through the process of biasing it today, so people can see me doing a bias process and learn from it, as well as figure out maybe if we can understand why the output is so weak and soft. It seems kind of distorted, almost like I'm slamming it really hard when I have it at max volume, but actual output to the speakers is very soft. So I'm very kind of boggled by that. And welcome, Phenom. Welcome to the show. I'm just going to give it a little bit longer until we hit the 7 o'clock time. We've got a couple people on as well besides you. But I'll recap it again after we get started, but that you probably heard a lot of that. So hopefully this will, and then if we can sort out what's going on with the output side, why it's so soft, then we will also try and attack the board. So the FET board seems to be giving me next to nothing, so we'll see how that goes as well. But just here, give it a few more minutes for people to join, and we'll figure that out from there. So if, as usual, if you have any questions, please do fire them off in the chat. I'll be trying to monitor that. Remember, there's a little bit of latency, so you might ask a question. But you're hearing what I'm saying sometimes a good minute or two behind what I'm actually really saying it, and so then I have to wait for you to respond to that, and then I respond back. So even when I do, you have to wait a minute or two for you to hear what's said. So there's a little bit of latency with that, with the live stream. It's not truly live, but we'll get there. So we're going to go through the bias procedure, and I'll explain what I'm doing first so that it makes sense, and then we'll figure what dissipation we're getting. And we're going to double check a few things general just with the power tubes to make sure they look like they're conducting correctly and doing what they should be. So yeah, give us just a minute or two here, everybody to join. We have about 2 more minutes, and then we'll get really rolling. How's everybody's week going so far? Mine's been busy. I'm on call. That's another thing I should call out. I'm on call for work, so if my phone starts going off, I might just have to end the live stream, and we'll resume at some other time in the future. But okay, so 2 more minutes, and we'll get going. If you'll notice, this time I've also got kind of a text editor up high up here on the top, and I'm going to try and make, hopefully that's fairly large font, because what I'm going to do is I'll put, oops, come on, the wrong spot. And we'll kind of be putting the content about that up there in the screen, but I want you to be able to see what I'm doing on the actual amp, as well as see my 2 multimeters. You've got one blocked by the live stream starting soon, but that'll be visible once I remove that as well. So, oh, really? That's my wife. She may be telling me there's something wrong with the stream. I don't know. We'll see. Hello, I'm just starting a live stream. What's up? I'm just starting a live stream. It's okay. All right. Okay. Bye. She's off visiting family. So, all right. But now that that's done, I think we're basically at the point I will remove the live stream. We'll start in a few minutes part here. On mouse. Where are you? There we go. All right. Okay, so to recap that for the few people that are here, maybe you already heard it, but what you're seeing right now is the first thing we're going to start off with is bias the tubes, or check the bias on the tubes. Make sure they're all at the same voltage potential, and everything seems to be okay, and they're conducting, and see what the output wattage is. We're going to go through that whole process to just do the math basically on that, and there's kind of 2 calculations you can check for the how much watt's putting out. The first one is at idle. You want to set your bias at idle, meaning there's nothing going through the amp. You turn the volume and everything down to minimum. and then you do the procedure, and then you can calculate from that exact amount of power it's doing. Yeah, thanks. Yeah, and so you can probably the Heiko devices have been like amazing. Like the only other stuff out there on the market is Heiko. I think really has just been like Weller. So those are the two brands that are outstanding. Yeah, thanks for that, Phenom. So we basically have I've got what this is I've connected the one side of this to the center tap of the power transformer, which also happens to be this first power supply node where the B plus first hits in. There's B plus 1 if you were to look at the schematic. The other half, each one is going to half of the power tube sides where the halves of the output transformer connect in. So what I'm going to be doing is what's called the transformer shunt method. Now this one is semi-dangerous. You want to make sure that you're very careful about doing what I'm doing right now. Power off. I connected everything up, and I happen to have 2 meters, so I can kind of do both of them at the same time. And I've written down, and we're going to write it up here as well. We're just going to do what I have to write. Let me get up here. So I have, on my right side is what I call green. So we'll do green. And for green, I've got, which one is green? That's the, okay, so that one's 46.2 ohms. So we're going to write 46.2 ohms. And then we're going to do, I think it's like a brown. And that one is 50.7 ohms. We're recording the, what that is that's the resistance on each half of the coils of the transformer. So the way that output transformer works is the center tap of the transformer connects to high voltage, sends the voltage to each half of the power tubes in the push-pull thing. And because we have 4 of them, then there's 2 of them sharing each half. And that means that the resistance roughly through each half of this transformer winding is 50.7 ohms on one half and 46.2 on the other. It's never perfect because wire is never perfect and they can never get them exactly perfectly balanced all the time. But the bigger point is we're just going to record that because the next thing we're going to do is we're going to record for each of those as well the voltage related to that that we read. And what that voltage is the voltage drop that goes between the that the transformer is drawing. Now, these multimeters have a very high resistance through them. It's like 10 meg ohm or something like that. So not much current can come through them, but you can use them to measure it, so they'll still be current able to go the other way. But we're going to turn our volume and our master volume down to the lowest setting. We're now going to switch these guys over to DC volts. Oops, that was off. So this one will be DC volts. That's set to DC volts. This guy, DC volts. And then we're going to power it on, and we should end up getting a voltage reading, which I will record for each of these halves. Once I've recorded those halves, I'll shut the power back off again, and then we're going to do some quick math and calculate where we're at. I also need to know what the maximum voltage is, so I will also need to temporarily take one of these guys out and just touch it to a grounding point to get the actual full voltage coming across. And I have tested the voltage. We'll double check those as well a little after this too, but you also want to check the voltage across all of the pins of each to make sure they're fairly consistent, and they were. The anode was, I don't remember the number, say 420, and the screen or the grid that comes off through that resistor was only like 3 or 4 volts below it. But so we'll go ahead and check those again just for you guys online so we can kind of talk through what that means. But let's first go ahead and power it on and get our voltage of these guys after they kind of warm up and get to current. And you'll watch, it's going to take it a while, but then they'll also start conducting, and then they'll start showing some voltages popping up on here. As you can see, it's starting to come. Now, this won't be a lot of voltage because it's just the difference between the center tap and anode, and that's going to be a couple volts. But that voltage over the resistance of the thing will tell you how many milliamp current are running through these tubes. And then what we can calculate from those is then what the exact milliamps of current each of the pairs of tubes is running. But since there's 2 tubes, we have to also have that because they'll it's 2 of them, so they're splitting it up. And then we'll see on either side as well. We'll also see about how closely balanced they are. So with my volume all the way down, we're starting to, I thought I was going to say we're starting to settle down, but it's still moving around a little bit. So effectively, though, we wanted to let this sit just a minute or 2 more to a more balanced, exact reading. Well, it's not exact, but fairly balanced, not moving too much. And see, this one you're seeing is kind of going up and down a little bit by a few, talking like hundredths of a volt, so it's not a huge amount. So what I'll do is, the left one was the brown one, I think. Oh, wait. I think I wrote those down backwards, because the left one is the fluke, was the first one I looked at, I think. But we'll write down, what I'll do is, they're both flukes, sorry. What I'm going to do is now that I've got those readings, we'll have to double check those. So what I'm going to do is 117, we'll call that one instead, the fluke 117 and the fluke 12. The 117 is reading 3 point, and you can see they're negative, but that doesn't matter. That just means I kind of inverted the voltage probe black and red. Really should have put black on this end and red to the center tap, but that's okay. Because the voltage is leaving through there and dropping down there, so it will be lower here. But I just kind of set them backwards on accident without thinking about it. So we got it looks like it's settled down pretty well to 3.71. So we'll just do 3.71 volts. And the 12 is 4.02, and that's been pretty rock solid there. It's not moving too much. So we're going to go ahead. Oh, I have it on half power mode. Look at that. I just noticed that. So let me shut it off. I just realized that. So we'll switch that back into full power mode. Turn it back on and see if that changes our voltage at all. Oh, it does look like it's changing it quite a bit. That makes sense because there's going to be about half the current running through them. So let's go ahead and change those. 117 is about 6.36, we'll say. And the 12 is 7.27. So now we'll shut back off again. And what I will kind of let that settle down. Effectively, what we do is we apply Ohm's law. And Ohm's law states that current is equal to the voltage divided by the resistance. And so we effectively are going to get a calculator now. And I'll bring that up there. We'll bring a calculator up here. And what we're going to do, let me double check my resistance now that I forgot that. So the Fluke 12 was the one that was 50.7. And I did mix my colors up. So we'll go back up here. Green is not the 46.2, is brown, so we'll just call that 117 as well. That's the Fluke 117. And down here is the Fluke 12. So those are just kind of to tie the two together. So we can then pull up the calculator again. And all we have to do at this point then is we had a voltage on the 117 of 6.36. Divide that by 46.2. And that gives us, oh, my calculator's not doing anything. What? Okay, there it is now. Must have. So let's try that again. 46.2. Oh, sorry, that backwards. Voltage is 6.36 divided by 46.2 equals, okay, so that's 130, let's just round up to 138 milliamps for 2 tubes. Divide that by 2, and you'll get per tube. And so per tube, we're running at 68 milliamps. That's actually kind of hot generally for this kind of an amp. But let's also look at, I need to get voltage at least on one of these guys. Like I said, actually we can do voltage for both. So we're going to switch this ground, each of them over just to a separate ground. And we'll turn it back on and get our voltage. We'll put back to voltage, DC voltage. And we're going to connect these guys both to a different separate grounding points. They don't need to be separate, but I don't have enough spot on that one to grab it. I'll just grab the transformer like that guy. All right, we're going to turn it back on. Let that come back up and we'll get our voltages. Well, that came up pretty quickly because the tubes are pretty warm. So we're running at 457. As you can see, they're pretty close on both of them. And I think those are fluctuating possibly partly because of that oscillation that I was hearing a little bit of. But so to calculate our power dissipation at this point, total, we would calculate that with the voltage. So the voltage is pretty much the same, 422 we'll call it. So we're going to come over here and we'll say voltage 422, right? So that means if you take the max voltage times the plate current and multiply those together, you get the actual wattage. Power times current is wattage. So we do 422, if we go back to our calculator, and we look at what we had there, we can times that by 422, and we get 29 watts per tube that we're dissipating. So that's 3 times 4 that's like 120 watts. That seems to me to be kind of egregious. And I think it's possible, oh, I should shut this back off again, that we're fairly high on our bias then if we're doing that. So one of the things you want to do then is dial that bias down to the minimum level setting and try and recycle this process to, the voltage will come down as you do it, but the bias and everything else will come down as well. So what I need to do then is I want to look at my negative bias Well, let's see. These guys were a pain in the butt to get clipped in. I did them before we started. I guess I could grab a third multimeter so I don't have to monkey with that too much. And this one I just have to quickly plug in a couple of simple probes and get my measurements of those. So let me grab my two really quickly here. And see which one. Those two work. All right, so I'm effectively going to just, I will try and kind of wedge this guy in a hole somewhere, because that doesn't need to be super strong. It just has to have ground. I'm trying to think of where a good spot to get me some ground would be, like right there. Right there. Then we put this on volts DC. That's AC. Millivolts. Volts. What do I do? There we go. Oh, it's just measuring millivolts. Okay, so we're going to turn it back on again. And what I'm going to do is that hopefully is also going to be visible. We'll set that up for you guys. We're showing no millivolts, but I'm going to go in and touch my bias reading here. And that's at negative 38 volts right now. But what I want to do to be able to pull off what I'm trying to do here is I want to get my, where's my screwdriver? There it is. We will adjust this a little bit and see what voltage level we're getting. So that way it goes up. So we want to go all the way down this way as far as we can. I'm just going to dial it all the way down. Oh, wait. Sorry. What? That doesn't make sense. I also want to, oh, there we go. Okay. I want to actually dial this up to maximum negative bias, because that means that it will reduce things. So we're up to 41, we're up to 41.4 volts. And now if you notice, this came down, oh no, the voltage went up a little bit. So what I want to do is restore those guys back to the centerpiece. So let's go ahead and shut back off again for a second, because, you know, clicking around with this kind of stuff with voltage running isn't very safe. I will check what my voltage is coming off of this guy, make sure it's draining. Yeah, it's down to 10 volts right now. All right, so what I need to do is get these guys back connected to here. I think that should work. Same with this guy. There's not a, the bigger problem I have is there's just not a ton of real estate to clip on with these guys, and I had to fight. Actually, I think I want to do this one first, because I remember it's kind of hard to get it in there right. And then this one's sticking out a little bit more, so it's a little easier. A little easier. I stand corrected. It's not a little, that's being a pain in my butt. Okay. So what we should be able to do quickly is go back to our ohms measurement and just see if that's still reading good, which means we have good continuity. It is. Okay. So we're going to go back to volts again. Volts DC. And we're going to power it back on again. And we're going to see what we changed to voltage-wise. So this voltage should adjust, because we've just adjusted the bias quite a bit to a slightly different negative bias. Give it a second to warm up, but you'll see these voltages are kind of coming up and they're staying lower. Instead of being at 6 volts, they're down to 5 volts. Now, one of the things I may have badly done here as well is I left the bias pot as it was that came with the amp, because I thought that would be in the right range, but because of the way Dumble does things, that might change. There is a, I think it's like a, I don't know, 15 or 17K resistor to ground on this guy. But on the Dumble, it said more like 27K. So I might need to actually swap that out if I can't get the bias of the range that I want. Because you do want 6L6s to generally run around for, you know, the 400 and, what was it, 420-ish volt range. You want it to be at maximum about 50 milliamps, 49 milliamps. That's a 70%. That's kind of hot. It's also generally smarter to at least bias it in the middle range, say 42 instead. But that's, you know, that's what you're shooting for generally, is that range. So I need to now look at it. Has settled down, so let's go back. Let's edit those numbers. So the 117 is showing it's at 5.1, 5.2. Say 5.2. Oops, I deleted an extra. Okay, and then down here, the Fluke 12 is 5.96. Okay, so now we can kind of do the math again. I will go and shut this off. Let's go ahead and look at the math of that again. Open the calculator. So the adjusted bias will now be 5.96 46.2 divided by, oh, I'm doing that backwards, that's resistance. It will be 5.2 divided by 46.2, and that gives me 192 milliamps. That almost went up, didn't it? Right, that did go up, because that's 96. I did that backwards. Is that seeming right to you guys? It seems like they're running really, really hot then. Let me try to adjust that negative bias the other direction quite a ways and see what we get. I was under the impression the negative bias had to be a slightly higher number for it to be better. I might be thinking backwards on that. So I'm getting no reading there. There we go. No. 41.6. Let's try and go the other way now. Now you should see the numbers of these voltages adjusting as I go too, right? Let's just go down to about 35. That's raised up to about 9 volts. So let me do the math on that now that we've adjusted that. Let's go ahead and clear. We've got 8.95 divided by, what's the 12? 50.7. That gives us a lower number. Let's divide that by 2. So we're down to 88. But we're still high for these tubes. So let's... Oh, geez, my dog barked and scared me. Okay, let's run it about there for a minute. Let's redo the math. So we're going to sit at 12.6. So 12.6 divided by 5.96. I'm sorry, 12.6 divided by 50.7. No, not 50.7 equals 248 divided by 2 equals 124. I'm going up, down. So I definitely don't want to leave them at that state because they will end up red plating and getting very unhappy. So I am going up. So that means that my maximum bias on the guy is pretty hot. Or my minimum bias. So I'll crank this back up to maximum bias. So we have maximum bias voltage, negative 41.4. And that brings us down to 5.96. So we could also do the math the other way around if we wanted to. If we wanted to do calculations that I wanted this at around, oh, what am I looking at? If I wanted it, because voltage runs at about 420-ish. If it was about 420 and I wanted about under 49 milliamps, we'd want 49 times 2. So we'll do, basically, we'll do it in milliamps. So we'll do 0.049 times 2. That's 0.98. So 0.98 is going to, so we'd have to do some voltage that we don't know yet, divided by 50.7 equals 0.98. So we want to times this by 50.7. And we get 4.96. So this needs to come down a whole volt more, which means I probably do need a different resistor on that. In the meantime, we're still we're biased a bit hot, but that doesn't mean it should lower the output. It just generally means that you're going to have some unwanted distortion and noise, I believe. So, but let's take a second then, shut this back off again. I will see, I think it called it in the Dumble one for like a 27K, and I don't remember if I have a 27K. Let's go back and look at the schematic of the Dumble really quickly. Their bias pot is here, and it's saying 27K. So, I'm trying to think if I have a 27K. If I do, you might take a little time. I'll turn my soldering iron and we'll desolder the one that's in there and replace it with one that is a higher resistance rating and see if we can bring that bias down. That would be my first thing, and if we can, then we'll be able to go from there. But I could also, because it's so hot, I could possibly even go, because like I said, that's like a 15K. I could possibly just go for something like a 32K as well, 33K or whatever. Because we just need to get it down into that a range where we can control it a bit better. So let me just see here really quickly with my resistors if I've got what I need. By the way, if any of you guys are seeing anything that seems like I'm doing wrong, do let me know. But I'm pretty sure that's the general process right there for doing that bias tap form. So this is 20. Oh, there's 24K. I mean, that might work. It's gonna get me closer to where I'm at now. We'll hold on to that for a second. Dropping stuff. Almost there. 270, that won't help. Those are some of my 1.8K, no. Alright. So, it looks like I'm going to have a choice between a 30, I think this is a 33K. Yeah, 33K and a 24K. So we will try, since it's supposed to be 27, I'm going to go for a little higher because the variable resistance will allow it to go lower, and we'll go from there. But so let's go ahead and adjust that really quickly. If anybody has any questions about the process as well, please do let me know. But so first thing I want to check is that I'm not going to electrocute myself. So we will put a quick test here. And we have no voltage. That's good. All right, so what I'm going to do is unplug it from the wall. I will turn my fan on for a second here so that I can not choke while I solder. I'm going to desolder that guy, take it out, and replace it with a 33K and see if that gets us able to adjust that bias a little bit better. All right. I've got too many things in the way here. Too many wires. All right. As I throw my pliers to the ground. So let's heat this guy up. There we go. Okay. So now what we'll do instead, we're going to try this 33K. Put a little bit more solder on that guy, on that side. That should be good. We will want to bend that lead over here. All right, we'll double check that that gets me good reading now. So we will get my snip here, remove my excess lead. Measure our resistance to ground. So we'll switch this over to resistance. That's interesting. saying it's open circuit, which doesn't make sense. It shouldn't. But wait a minute. I've wired this bias switch wrong. I think. I'm using it as a variable resistor to ground, and that's not right. This is 27K that's supposed to be from the output to ground. The input... Oh yeah, I'm looking at that and trying to figure that out. I think I actually got that wired wrong. Let's zoom in a little bit so you can see. This was wired as a bias balance pot. That's what I'm doing wrong. I need to adjust this to it's like this, which is, let me move that a little higher. So I have the 10K pot, but the input is to come in here from this side, which is right. The output is supposed to go to the 27K to ground, and the middle is supposed to be where that, geez. All right, so let's fix that. So my bias adjustment pot, I think it was doing something, but not what I was thinking it was doing, so. I need to pull this guy out. There's my pliers. I still was getting biased, don't get me wrong, but... So, this might be fun to get this to the right. Let's go ahead and suck that away. Clean up that mess that I have down there. Alright, I think I got most of that away. We'll go ahead. Let's redo this guy right. So I've got this 3K connected to the other end of the pot now instead in the correct place. And then I will connect the wire to the middle, the wiper of the pot. And I should be in good shape. Actually, I've made that look kind of ugly, so let's... I'm gonna straighten that out and clean up a little bit of the, I've accidentally done a little bit of mangling to the bias wire here, so we're gonna clean that a little. I've melted the lead a little bit trying to get it, so we will scrape off a little more. See how I've gotten that kind of melted? I want to clean that up so it looks a little nicer. There we go. Let's go ahead and solder that in. And then we will try and see if we can readjust this bias a bit better. I'm not getting that in good. Okay, we'll let that sit. There we go. All right. So now, what I'm going to want to do is see kind of quickly here what my bias voltage is at. And we've got this on the wrong mode. Let's put it back to voltage. And bias voltage will be coming out of the center of the pot instead of the... So we're going to quickly flick the power on. That's AC. That always makes me nervous. I didn't get any voltage coming off of that. So let me think for a second and make sure. I should have roughly 27K to ground. Let's go back to resistance. Oh, whoops. Not 27, but 33K. It's going to charge up the capacitors first and should slowly climb its way up to 33K. And it is. So we're at 33K to ground off of the back end, which is good. And we have, so, let's see. I need to see what the resistance is between these guys. Oh, come on. Very low, like 6 ohms. And that means that the maximum negative bias should be going. Okay, so that's a good sign. So that means we should be getting maximum negative bias. So let me try and turn this back on after I get myself positioned to where I can hopefully read that negative bias. Oh, that's resistance. The tubes look dark. And I'm getting no bias voltage. Hold on. That's making me nervous. It could be just me, my meter is doing something stupid, but... Oh, I unplugged it from the wall. I'm like, why am I getting no voltage there? It helps to have the amp plugged in. So we're having... Oh! I don't like seeing arcs. Negative 57 volts there. Negative 58 volts there. Alright, that's a better sign. And I seem to be having no current, like really low voltage here, but this could be warming up and coming up. 1 volt there, nothing on this side. Interesting. Let me double check my voltage. Negative 58. So I may be in the kind of cutoff range right now. On one half, and the other half is barely conducting a little bit. So that means that I possibly want to come up a little bit to get myself, again, we said we want our voltage to be around, let's see if I can pull that back up again. 4.9. So let's try to dial it up to there first and see what that gets us. Interestingly enough, I'm not getting anything on this one. Did I accidentally disconnect it? Why am I not getting any volts on this guy? And I am on that side. So this is definitely in a better range for what I want, but for some reason I'm not getting... Let me see also what volt I've got. 432 volts there. 403 volts. Like I said, it's 2 or 3 volts difference there. Okay, so I'm getting voltage. I don't know what I've done wrong here on this guy. For some reason, I am not getting any actual reading off this other one all of a sudden, which I was before. That's really weird. I see all the tubes glowing. They're all doing something, but for some reason, I'm not getting anything out of that side. Let me hit power off to save myself from shocking to death. And we're going to test and see if I can just kind of reconnect to make sure I'm getting a good connection there. Voltage has dropped down to 60 volts. So now I have my bias wired correctly. Again, I assumed that the Fender had it right, and then I forgot. This is what happens when you make assumptions. I forgot that the Fender used a bias balance pot, not a bias pot. So I now have it hooked up as a bias, and I can adjust the bias in the range that I want. So that's all good stuff. So voltages are now down to 8 volts. That's safe enough for me to get in there. So for some reason or other, let's put these in resistance reading mode. Yeah, so something in my connections just being wonky with this guy. Let's look and see which one it is. Either this one. Ah, this looks like it might not be connected anymore. Let's try again. There we go. That's why. Okay, so there's no need to panic. Let's go back to volts, and we'll see where we're at. So we are going to bring it up. We should hopefully get, like I said, near that 4.96 or around 5 volts. And I might not quite be there. I got to about 4 something and stopped because I couldn't remember which side was higher. But we can then adjust this bias right up near that range, see what we get. And I'll check my max voltage. And we'll do the math again, and we should hopefully be biased perfectly. Once we're there, I'm going to turn it back on and put the guitar in and see if that helped the sound. It is possible it was just biased too hot, which can actually kind of be damaging the tubes. They weren't red playing or anything, but they were running pretty hot. I don't think that should cause it to sound weak or soft. It should usually just sound just as loud, but kind of crappy. But I could be wrong on that, so somebody could tell me if I'm smoking something funny. Let's give it a second here. All right, so it's balanced out at 4.2 on this one, which is the one we wanted at 4.96. So let's get my meter or my voltage rating here again. 45.8. And we will adjust and keep adjusting until we get closer to 5. And sometimes you hit the target you want and you have to readjust slightly because the voltages adjust as you go. So I'm going to be a little low on purpose. 4.8 volts. Do the math of that again. We're going to pull up, first I'm going to pull up my notes. Then we're going to pull back this guy up as well. And we're going to do clear this out. So we have the Fluke 12 has 4.82 volts divided by 50.7. That gives me 95. Divide that by 2. That's a total of 47. Look at that. That's perfect. That's exactly what I want to buy. So let's double check the math on the other half and make sure that it's within the range. So the other side, we've got 4.13 volts divided by 46.2. That, and then divide that by the 2 tubes, and we get 44.6. Wow, that's perfect. We're dialed in. So my bias is set well. So we're going to go ahead and I'm going to shut the amp off for a second. I'm going to disconnect these guys because the bias is exactly where I want it. I do not need them hooked up anymore. Oh, I do need to keep one of them connected because I want to get my max voltage. So let's look. But this one will go instead to ground. And we will, this goes to which one? I'm trying to figure that out. I think it was this other one. Yes, all right, so we'll move this guy out of the way, shut it off. We don't need it anymore. And we'll turn power back on long enough to, I'll turn this fan off. So we are at higher voltage because of this. It was, oh, it's a little high at first, but it's conducting. Okay, so let's see. So we ended up at, we're going at 44 per tube. So let's just round that up to 45. 40.045 times 4 equals, so that's 180 milliamps for the whole amp running at 428 volts. Times that by 428 equals 77.04 watts of power. And that is about what these guys should do at no volume, right? There's no volume going through it. Now, if I was to crank the volume up and redo the calculations, I would be able to calculate max power. But that's at distortion. That's not really a good estimate. You usually want to get max clean power, so you'd have to get a sine wave input at 1 kilohertz. There's some stuff that I might try and do at another point to kind of show that later. But for now, I just wanted to get it biased right. It is biased correctly. So let me go ahead and turn the volume up and just see what it sounds like. Oh, why am I getting no output? Okay, that's weird. Oh, I'm in the Fed input. I was looking at Fed input. There we go. We have sound, right? So if I keep, see, there's my oscillation I was mentioning. I don't know why that happens. It doesn't sound pretty though. And that is not, let's see how distorted that sounds. This is at max volume too. I turn the volume down a little bit. We no longer have that, right? It's a little bit there. Here's the preamp boost. Really squeal. And then here, also adds some squeal. So one of the things I now need to try and figure out, and I'm actually kind of running out of time, but I want to see why or where that squeal is coming from. So what I should do is get this guy out of our way. And I'm going to adjust my camera a little bit. So what I'm going to do now is we don't need those guys down below, so we're going to go ahead and close that out, minimize this, and we will go ahead and move this guy down a little bit. Come on. Out of back to the corner where it was before. And we're going to look at, I'm going to input a sine wave in. And we're going to see if we can, I'm going to try and keep the volume down a little bit, but we're going to see if we can get to the point where it starts creating that obnoxious noise and see if we can find what stage seems to be getting that. Now, one of the things that was one of my theories, I possibly could test really quickly since I was soldering iron out, was that that's actually the phase problems with my output transformer. Because I have a negative feedback, if I switch the leads, it may go away. It may just be an oscillation being created by those being out of phase. Usually it's more like a howl sound, but I have heard some people saying that they have found some really weird issues that were fixed by just swapping the leads. I'm kind of tempted that maybe I should just say bag it and let's swap the leads and see what we get. Decisions. Well, yeah, I don't know. Let me adjust the camera up so that we can look and see the oscilloscope. Into the oscilloscope view. Does that look like that's in focus? We'll have to wait and see for a second, but all right. Okay, so for whatever reason, that squealing noise is definitely no fun. Let's turn the volume down. Actually, I'm gonna turn the, so let me get this guy out of the way and this guy out of the way. Oh, geez, that's not safe. All right, let me turn that off. The whole thing came out. I don't want to touch that now until I'm sure there's no electricity flowing through it, or I will be dancing. That's down to 35 volts, 25, 18. All right, that's a range I feel comfortable with. It's like bare metal, and I'm touching metal, and I don't want to do that with power coming through it. All right, so I don't know how that happened exactly, but we'll try and fix that. All right, that's fixed. So basically, let's see. I've got the input sine wave connected to there, and that's working. I've got the volume turned low, so let's turn, or actually the volume, that's at max. Let's turn the max volume up a teeny bit. Why am I, oh, I've got it off. I was like, why am I getting output? We're going to have to look at channel 1. I'm going to need that probably. I've got it connected to the speaker output. And it'll only run about, this is an interesting thing, is that the output transformer, your voltage coming into the power tubes is like 20 or 50 volts or whatever, but as it comes out to the output transformer, it reduces the voltage and adjusts the impedance, so it's only like, I think it was like 7 or 8 volts. You'll see it here, but you'll see it in a second once I get it going. So now you can hear it a little bit. And that is, I'm on 1 volt. It's only like 2 volts, but it's not high volume, but we're also not getting any weird noise. We're starting to square wave out the output a little bit. Let me stop looking at this at this point. I'm going to look at it out of curiosity at the phase inverter. This is the output to the phase inverter. And that's so big that it's not showing up anymore. Sorry for the obnoxious sine wave. it's DC coupled. I don't know why it defaults to that. It should be AC coupled. So as you can see, this is actually pretty big. We're at 10 volts, and it covers the whole thing, which is probably like 80 volts. That's pretty hot, but it's still a clean sine wave. And I can adjust that with the master volume, because the master volume is right before the inverter. But the output coming out of the channel 1 from the master volume onto the speaker is fairly low. So I've got down 100 millivolts. We're like in the 100 millivolts range, and that's part of why it's so quiet. That doesn't make sense to me. That's with the drive channel, and you can see that creates a nice... Actually, I like to see this. This is kind of cool. Let me adjust the time base. See how the drive changes the way that looks? They're kind of overlapping. Let me move those down a little. It's not right on each other. So if you watch, if I kick in the drive, it creates a pretty significant change. And the preamp boost does as well. Or maybe those are both correct, and that's the preamp boost and drive. But effectively, I'm not getting the oscillation at all. It's very clean looking. But when I put my guitar in it, it starts oscillating like crazy. So it's kind of weird that when I plug in this, it actually comes out kind of loud, not massively loud, but that's maximum output, right? Oh wait, that's maximum output. That is loud. Huh. But if I now shut this, if I turn the volume back down and unplug that for a minute and plug back in the guitar, you'll hear it does not sound that nice. That's actually fairly clean sounding. Could it be a cable problem or something related to my... No, because I also, you'll see when I turn this up, we still get decent looking signal, but there's a lot, there almost seems like... Can you see the little bit of weird glitchiness riding across the top of the signal? That's the preamp boost, I think, is all. So this isn't very loud, and now you can hear a little bit of the squealings trying to happen too. Or maybe that's just buzz from this crappy guitar. I don't know. If I touch my hand to it, it disappears. Turn the master volume is max though. This is at max volume. See, it's starting to squeal already. See all of that hashy stuff going on? This is just not very loud though. I don't know if it's clipping or not for you guys, but it is definitely not loud in here. Now I'm getting the squeal. I don't know. So that's something I still need to try and research some more. I might leave this obnoxious squeal going on. See if I can turn it down a bit. And see if touching components resolves it, but I don't want the feedback happening. So let me stick the cloth under the strings, or on the strings here. So you can hear that horrible buzzy noise going on. Well, now it's gone. Well, I'm still not getting a lot of volume though. It was weird. That may very well be the preamp boost. I don't know. I was saying before I thought these were switched, but so with the preamp boost on, let's just do a little touching with the chopstick. See if anything changes it. So those switches are both working. So one of the things I haven't really done much with is this guy. I don't know for sure if the drive is even on. It doesn't seem to affect it. So that's proof this is proof that this is backwards, because I've now got the green light on, and adjusting that pot does adjust how much drive it gets. So I could crank it all the way up if I wanted to, but I don't think that's wise. But anyway, so I definitely don't understand the squeal. It could just be a really noisy guitar or a noisy guitar cable or all the other crap I've got on around here, but I do know that it's very soft. So, so if I get this guitar up right now, I'm just at max volume right now, and it's not very loud, but it has a cleanish, I mean, it's driven, but not horrible. Let me turn the main volume down a bit. So I'm not feeling an overwhelming, oh, this is definitely sounding right, but we'll look into that. So it does seem pretty okay. So let's test a few things. For example, here's the bright switch. Oh yeah, I can hear the brightness coming back on that. Bass. Let's turn the bass all the way on. Oh, that's treble. Sorry, treble. Oh, I just heard some of the squealing coming back. Mid. That's mid scooped. Mid to max. Bass. Yeah, I can feel it. So the treble, middle, bass are working right. Yeah, I can hear that. I like that down better. I can't remember if that's the rock, jazz, or if that's the deep switch. Here's the drum. So we're going to have to sort out, there's the ceiling again. So if you can look, that squealing is horrible. But I don't seem to be able to figure anything causing it. Well, but the weird thing is, if I put a sine wave in, it sounds perfectly fine off of this guy, which makes me start to wonder if it's just a crappy guitar or a crappy guitar cable causing the problem. I might have to take another day and try and play with that. So, at any rate, we've got the bias adjusted correctly, and I'm kind of running out of time. I'll have to kind of come back to this later. Let's go ahead and shut that noisy stuff down. I welcome any suggestions people might have to help me figure that out. I'm going to probably continue troubleshooting offline and see if I can figure it out. But at least hopefully this video helped people understand the general bias method that I've used, which is called the transformer shunt bias method. So Please do give me comments, suggestions, likes, and thumbs up and subscribes. Thanks, everybody. It's getting me down a little bit, but it's not getting me down too much. I'll keep at it. We'll see if we can figure out what's going on here. Thanks, everybody. Cheers.